Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 5, Conic Sections. Section 46, Desargues' Theorem on Conics. Theorem 19. If the vertices of a complete quadrangle are on a conic which meets a line in 2 points, the latter are a pair in the involution determined on the line by the pairs of opposite sides of the quadrangle. Footnote, first given by Desargues in 1639, chiefly Paris, Volume 1, 1864, page 188. Proof. Reverting to the proof of Theorem 2, figure 51, let the line meet the conic in the points B2, C1, and let the vertices of the quadrangle be A1, A2, B1, C2. This quadrangle determines on the line an involution in which S, A, and TU are conjugate pairs. But in the proof of Theorem 2, we saw that the quadrangle A1, A2, BC determines the quadrangular set of B2ST, C1AU. Hence, the two quadrangles determine the same involution on the line, and therefore B2C1 are a pair of involution determined by the quadrangle A1, A2, B1, C2. Since the quadrangles A1, A2, B1, C2 and A1, A2, BC determine the same involution on the line when the latter is a tangent to the conic, we have a special case of the above theorem. Corollary. If the vertices of a complete quadrangle are on a conic, the pairs of opposite sides meet the tangent at any other point in the pairs of an involution of which the point of contact of the tangent is a double point. The Desargues theorem leads to a slightly different form of the statement for the construction of a conic through 5 points. On any line through one of the points of a complete quadrangle, of the other 4 determine an involution. The conjugate in this involution of the given point on the line is a 6th point on the conic. As the Desargues theorem is related to the theorem of Pascal, so are certain degenerate cases of the Desargues theorem related to the degenerate cases of the theorem of Pascal. Theorems 6, 7, 8, and 9. Thus, in figure 53, we see, by Theorem 6, that the quadrangle BC P2 P5 determines on the line P3 P4 an involution in which the points P3 P4 of the conic are one pair, while the points determined by the line P1 and P2 P5 and those determined by P1 P2, P1 P5 are 2 other pairs. This gives the following special case of the theorem of Desargues. Theorem 20. If the vertices of a triangle are on a conic and a line L meets the conic in 2 points, the latter are a pair of the involution determined by L by the pair of points in which 2 sides of the triangle meet L, and the pair in which the third side and the tangent at the opposite vertex meet L. In case L is a tangent to the conic, the point of contact is a double point of this involution. In terms of this theorem, we may state the construction of a conic through 4 points and a tangent to a line through one of them as follows. On any line through one of the points which is not on the tangent, an involution is determined in which the tangent and the line passing through the other 2 points determine one pair, and the lines joining the point of contact to the other 2 points determines another pair. The conjugate of the given point on the line in this involution is a point of the conic. A further degenerate case is derived either from Theorem 7 or Theorem 8. In figure 54, Theorem 7, let L be the line P2, P3. The quadrangle AB, P1, P4 determines on L an involution in which P2, P3 are one pair, and in which the tangents at P1, P4 determine another pair, and in which the line P1, P4 determines a double point. Hence we have Theorem 21. If a line L meets a conic in 2 points and P1, P4 are any other 2 points on the conic, the points in which L meets the conic are a pair of an involution through a double point of which passes the line P1, P4, and through a pair of conjugate points of which pass the tangents at P1, P4. If L is tangent to the conic, the point of contact is the second double point of this involution. The construction of the conic corresponding to this theorem may be stated as follows. Given two tangents and their points of contact, and one other point of the conic, on any line L through the latter point is determined an involution of which one double point is the intersection with L of the line joining the 2 points of contact, and of which one pair is the pair of intersections with L of the 2 tangents. The conjugate in this involution of the given point of the conic on L is a point of the conic. Exercise. State the duals of the theorem in this section.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.